So welcome back to the new session. Join. If the two students who have joined, if you have any queries regarding the previous session, you can ask me. You can unmute yourself and you can ask me. So I hope that you have understood everything. Okay. So now people are not joining. Okay, if I do, okay, someone has written something. No question. Okay, very good. You, if you, I must say that if you don't, if you have any doubt in your mind, then you can anytime. You don't have to hesitate. You can anytime you can stop me and you can unmute yourself. You can raise your hand. If you raise your hand, I will get to know that you want to say something to me, and you can unmute yourself and you can ask me questions because I'm here to answer your questions, your queries. Okay, so don't worry, don't hesitate. Now the case is that we have to deal with a situation. We have to deal with a situation when we do not know we do not know anything we do not know anything about mu and sigma. So you are dealing with a population. We are dealing with a population where mu and sigma are not known to you. Mu and sigma are not known. Previously, in the previous session, we knew about mu and sigma, but now we do not know anything about mu and sigma. So this is our case 2 actually. So how to deal with this kind of thing? First of all, tell me. Let me tell you. Okay, I shouldn't say tell me because you don't know it. Okay, so what we do actually is that when mu is not known, we try to estimate it. We try to estimate mu with something called grand mean. Something called grand mean, and in the note you will get to see that grand mean is actually denoted by x bar bar. If the note is in front of you, we'll get to see that this particular quantity is denoted by x bar bar. That is called grand mean actually. And mathematically we write that this estimate of mu, since mu is not known, is denoted actually by mu cap, and mu cap is nothing but your x bar bar. Okay, and what is x bar bar? What is the formula of x bar bar as it is given in the book? I'm going very slowly because so that you find it comfortable. So I'm not moving fast. So x bar bar is actually mean of means. And if we want to write it explicitly, then we call it as x1 bar, that is also a mean, x2 bar plus dot 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 plus x n bar. How many items are there? N items are there. So these individually, these xi bars are also means. Okay, individually they are means, and we calculate the mean and their means are taken. So that is called, sometimes it is called grand mean also. Grand mean. You have to know, you have to keep it in your mind because this grand mean is not only used in statistical quality control, the another module which I will be dealing with, the design of experiment, the factorial design, etc., etc., you will get to see that grand mean plays a very important role over there. Now, since it is a grand mean, so mu is not known. Since mu is not known, since, let me write over here, why I am calculating the grand mean. Let me clarify. Since mu is not known, okay, this is my case over here. So how can I calculate? Question is, how can I calculate? How can I calculate UCL and LCL? Because in UCL and LCL, you know, we actually require what? Mu plus something. Something I'm not talking about right now, mu plus something. So mu is not known. This is not known. So since mu is not known, in the formula of LCL or UCL, we replace mu by mu cap or x bar bar. So in place of this, we'll have to write, okay, since mu is not known, we shall replace it by x bar bar. So therefore x bar bar is required. So we are actually trying to estimate mu by this quantity. Now, how to calculate x bar bar? Formula is given to you. In summation, with the help of summation, we can write it as, this is summation I goes from 1 to n xi bar by n. Okay, so this is the formula written in with the help of summation sign. But I know that you are not feeling comfortable when I use too many of notations. So let us try to discuss. Forget about X bar chart and R chart. I'm not going into the details right now. I'm moving very slowly. So let's only talk about how we calculate X bar bar. Okay, so let us choose one example. As for example, take 4 samples. Take 4 samples, each of size 2, as follows. Suppose it's an example I'm showing you how to let you know how we calculate X bar bar. Take 4 samples, each of size 2, as follows. Okay, how do you want to select the samples? Say your S1 is sample 1, and that is equal to, say, first value is 1, second value is 2. If you ask me, what are these 1 and 2? Nothing. From just mathematical purpose, from pedagogical point of view, I am considering this value 1 and 2. Okay, just to let you know how to calculate X bar bar. And if you ask me that, sir, please give me an example, a practical example, what will be 1 and 2? Say, for example, you are producing screw, and in sample 1, you are choosing two screws, and you are calculating the axle diameter of the first screw and the axle diameter of the second screw. So the first value here will be the axle diameter of the first screw, axle diameter of the second screw. That is your sample 1. Put it aside. Then shuffle and choose another 2 screws. Axle diameter, note down the axle diameter and the axle diameter. That is your sample 2. So let us choose sample S2 as, which is called sample 2, and you are noting the axle diameters. Now I am just arbitrarily putting the values. Okay, sample 3, I'm choosing it as 1,3, and sample 4, S4, I'm choosing it as 2,1. Okay, so you see each of these samples are what? How many samples are there? In total, there are 4 samples. Okay, in total, there are 4 samples, and each of these samples are having size 2 because 2 items are contained in it. It would be nice if you replace this particular small n, by capital N. Why am I doing so? Because in this case sample size small n is 2. Here also sample size small n is 2. Here also sample size small n is 2. Here also sample size small n is 2. In total, how many samples are there? That is your grand sample size, which is I am denoting by capital N. In the book, it is denoted by small n. So there will be some notational ambiguities. So it would be nice if you denote the two sample sizes by two different notations, because otherwise you may think that that small n and that capital N will always be same. It is not like that. Okay, so we have selected this samples. Now I'm going to calculate grand mean. Question is find grand mean. Okay, that is the question. Now can I go to the next page? Have you copied? Can I go to the next page? Someone please write in the chat box. And again, I have to consider this particular page also, because I have to come back to this page again and again. So if you have not copied, then don't worry. Okay, so let us okay, 3 students are saying yes. So okay, with your permission, I'm going to the next page. I'm going to calculate grand mean from there using this particular formula. Okay, so you see how to calculate the grand mean. Solution: the mean of x bar, the mean of sorry, not x bar, s1. Let us denote this by x1 bar. It is nothing but enter. Okay, someone has written the n is has not she has not understood n. You see who has written it? Moshumi. Carefully observe that 4 samples have been selected. Okay, now from in each of these samples you are putting 2 values, 2 items. So if I talk about sample 1, then what is the size of the sample? How many items are there? 2. So here I am denoting this sample size by n, whose value is 2. And in every other case, the sample size is 2, because each pair contains 2 items. How many samples in general you have considered? You have taken 4 samples in total with size 2. So that size, mother size is 4. How many samples you have chosen? S1, S2, S3, S4. Therefore, that is called that is being denoted by capital N. Okay, grand size of the sample, that is capital N. Have you understood? Moshumi, have you understood? Okay, so let us calculate this. So the mean of S1, that would be what? X1 bar. X1 bar means the items present in X1, that is X1, small x1, I am denoting small x1 and small x2 by 2. What is the small value of small x1? Small x1 is, look at the pair, small x1 is 1 and small x2 is 2. Okay, so first value is 1 and the second value is 2, and that divide by 2 because 2 items are there only. So this would be 3 by 2, which is 1.5. That is your x1 bar. The mean of S2, let us denote this by x2 bar. Again, this will be x1 plus x2 by 2. I am using small x over here, and that is capital X. Small letters are used to denote elements. Capital letters are actually, okay, let me not take the term, because that is also in module 1 and 2. Ma'am will talk about it. Talk about that. So in here also 1 and 1. So 1 plus 1 by 2, and that is 2 by 2, which is 1, and the mean of S3, which is x3 bar, that is x1 plus x2 by 2, and that is, look at the values, 1 and 3, 1 and 3, so that would be 1 plus 3 by 2, and that is 4 by 2, that is 2, and the last one is the mean of S4, which we denote by x4 bar, that is x1 plus x2 by 2, and what are the values? 2 and 1. So let us write over here 2 plus 1 by 2, which is 3 by 2, 1.5. Okay. So we have calculated 4 values: x1 bar, x2 bar, x3 bar, x4 bar. Therefore, the grand mean, which we denote by x bar bar, that would be equal to x1 bar plus x2 bar plus x3 bar plus x4 bar divided by 4, because 4 items are there in total, and that would be 1.5 plus 1 plus 2 plus 1.5 divided by 4, and 1.5 into 2, that is 3, 3 plus 2, that is 5, 5 plus 1, that is 6, so we get 6 by 4, that is 3 by 2, that is 1.5. So grand mean is also 1.5. Okay, grand mean value is also 1.5, and the grand mean is actually your estimate of mu, the population mean. So if I talk about this formula, mu plus 3 sigma by root n, and since mu is not known, so we have to replace mu by mu cap, 3 sigma by root n, and mu cap is actually the grand mean, that is x bar bar plus 3 sigma by root n. Okay, let us keep this aside, we are not talking about it right now. So we have actually calculated in the limit, we have actually calculated, in this limit we have actually calculated the estimate of population mean. We want the upper control limit and the lower control limit, we are interested about that. So we have calculated here one part of the upper control limit and one part of the upper control limit, that is the first part. The second part has not been calculated yet, so that's why we calculate x bar bar, okay, to calculate the limits. Now I hope you have understood this calculation. Okay, now you see whose question is this? Ahona. Ahona, look at this. See, what is my objective? My objective is to calculate UCL and LCL. To calculate upper control limit, we need what? Two items. One item is called mu and another item is called sigma. So if these two items are known, so we put mu over here, then we put a plus sign, we multiply 3 by root n by sigma. That is the formula we know. And similarly, lower control limit is the same thing, only minus sign is put in between. Okay, let me finish this part. Now see, if this formula can be used this formula can be used only when this mu is known to me. But suppose the situation where population mean is not known, mu is unknown. So how to calculate? If mu is unknown, how to calculate this limit? We will not be able to calculate upper control limit. So if population mean is unknown and upper control limit and lower control limit is not being calculated for this, then what should we do? Shall we stop the production process and tell everyone that, okay, I do not know the population mean, so I'm closing my factory? Okay, workers don't have to come. Okay, sorry for this sudden interruption in the network connection. I have lost my board work, but don't worry. I'm there with, if you need the board work, I can again write. Okay, I am the question I was answering. First of all, if suppose population mean is not with me, and we want to calculate, we are not able to calculate UCL and LCL because this part is not known. So shall we stop our production process? No. So therefore, I am replacing mu by a quantity which is called grand mean. And if grand mean can be calculated, I can replace mu by, in the UCL formula, I can replace mu by the grand mean, x bar bar. That's why I have calculated x bar bar. Now, Ohana was asking that how did I get x1 and x2? The meaning of this term is x1 means x is a variable element. It means the first value of the variable x. And this is called the second value of the variable x. I chose the sample S1, say for example in this manner, 1 1. So what is the first value of the variable x? That is called x1. What is the second value of the variable x? That is called x2. So from there I have got the x1 and x2s from all the 4 samples. Probably you have understood. Okay, so that's why I have calculated x bar bar, and in our case the x bar bar has come out to be 1.5. In our case the x bar bar has come out to be 1.5. Now also in this case 2, we are dealing with case 2, remember. So also in this case 2, another thing which is required for UCL and LCL, that is sigma. Sigma is there, 3 sigma by root n, if you can recall, and mu minus 3 sigma by root n. This sigma is also unknown. We also do not know anything about sigma. What is sigma? Sigma is called the population standard deviation. In the last class, I have discussed how to calculate the standard deviation. Okay, so I'm not going to talk about that right now. Population standard deviation. So since population standard deviation is not known, so what shall I do? How can I find this particular item? How can I find this particular item? That is a big question. And you know that sample small n, in the grand sample size was capital N, that is was 4. And here in the formula, I'm talking about small sample size, that is small n. So I actually know this sample size. This sample size is known. 3 is a constant quantity that is known. Only a problem is sigma. Sigma is not known. So how to calculate sigma? How to know sigma? We cannot calculate sigma, but we have to estimate it. Since sigma is not known, we have to estimate. We have to estimate the sigma also, the standard deviation sigma also. But how to estimate this? According to the book, there is a formula given in equation number 16.3, I think. Let me tell you the equation number. Equation number according to your note is 16.5. You will get to see, no, 16.6. You will get to see that if sigma is not known, we estimate sigma by, we write it as sigma cap. Cap means estimator. It is a notation. Sigma cap means estimate of sigma. The formula is given by R bar. Sorry, let me write it properly. R bar by D2. Now I have to explain what is R bar and what is D2. D2. I have to explain what is R bar and what is D2. Okay. And you will see that in the equation number 16.5. So I'm talking about equation number 16.5 of your note. and equation number 16.6 of your note. Okay, so according to these equations, you will get to see that this quantity R bar is actually given by 1 by n, 1 by n summation I goes from 1 to n Ri. And what is R? What if we write it explicitly? What it means? It means, if we write it explicitly, it means R1 plus R2 plus dot 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 plus Rn by small n. What is R? What is R? R is called range. R is called range. Now I am going to explain this particular part now. I am going to explain how to calculate estimate of sigma with the help of this formula and this formula. And I am again considering the question which I considered. My question was, my example was, I considered the sample. I considered 4 sample. First sample looked like this, 1 2. Second sample looked like 1 1. Third sample looked like 1 3, and fourth sample looked like 2 comma 1. With respect to this, with respect to my example, I am going to calculate R bar and tell you how to estimate sigma with the help of the formula R bar by D2. First of all, let us only talk about R bar. And D2 is something which will be discussed later. Okay. So can I proceed to the next page? Students, please write in the chat box, otherwise I will not understand. So that I can proceed. Do not ask me anything. What does it mean? Because I have not explained yet. Yes, okay. Thank you. So, yes, Moshami also said yes. Okay, fine. So I am actually in the next page, I am going to calculate R. Okay. What is, first of all, as it is given that R is equal to range. So first of all, you have to know what range is. Question is, what is range? Range is actually a measurement of another kind of measurement of deviation. Range is a measurement. Range is a measurement of deviation. What is deviation? Suppose you have set for an examination and total mark of the examination is, say, for example, 30. That is the total mark. And suppose you have got your mark is 25. So you will say what? Sir, I am 5 marks less than 30. So that quantity 5 is your deviation from the mark 30. The difference, how much you are deviated from this value, that is called the deviation. This 5 is called the deviation in statistical term. Okay, very briefly I am saying from pedagogical point of view, ma'am is going to talk about deviation and how to calculate that. Okay, I'm going to talk about range only. Now suppose how to calculate range. How to calculate range. Okay, now the countdown for this session has started, so probably I have to carry this particular discussion to the next session also. So we have 9 minutes 53 seconds left, so let's try to discuss as much as I can in this particular session. Suppose we have a sample x1 x2 dot 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 xn. This is the first value of the sample, this is the second value of the sample, this is the nth value of the sample. Okay, suppose you have a sample of like this. This is the first value of the sample. Okay, this is the second value, and this is the last value of the sample. Okay, now to calculate range, to calculate range, we use the following formula. Okay, we write, if we denote range by R, we, the formula is very simple. We write it as last value of the sample minus first value. Or if you want to write it mathematically, so last value is xn and the first value is x1. Simple as it is. Okay, so that is the formula of range. Now let us talk about my sample. My samples. My sample was S1. S1 contained two values. The value of x1 was 2. The value of x2 was value of x1 was 1 and value of x2 was 2. My second sample, value of x1 was 1 and value of x2 was 1. My third sample, value of x1 was 1, value of x2 was 3. And my fourth sample, let me write over here, my fourth sample S4, the value of x1 was 2 and value of x2 was 1. Now, if you ask me what will be the range in this particular case, so for this range R1, I am considering the range of S1 as R1, okay, because the 4 ranges will be calculated. This is the first range, second range, third range, fourth range. So that will be last value minus first value. Let us keep it in, put it inside a box. It is a formula, you have to know it. Okay, and I'm recording this video, say our today's session. So I'm going to, if I can upload the today's video, because you know in the last class there were too many disturbances of network, so I couldn't record anything. Today is getting recorded, so if I can upload the video in the YouTube, you will get to see, get everything. You will get to see, you can revisit once again to the following lecture if I can upload. It is by, because my network is actually troubling a lot for last couple of days. So this is your R1. So what is the first value? First value is 1. What is the second value? That is 2. So the range will be x2 minus x1, which is 2 minus 1, that is 1. Here R2 is the range of the second one. The first value is, last value is x2, the first value is x1, so that is 1 minus 1, that is 0. No other values are there, na? So only one first value and last value is there, so therefore, but here in this case other values are there in between. So in calculation of range we only consider the last value and the first value, always remember. For the second one we calculate R3, and that is also once again x2 minus x1, that is the first last value, that is 3, and the first value, that is 1, that is difference is 2. And similarly for the last one, range 4, it is last value minus first value, which is, 1 minus 2, that is minus 1. Which one is 0? Which one you are talking about? I have written 0 over here. This is 2 minus 1, that is 1. That is 1 minus 1, that is 0. That is 3 minus 1, 2. And that is 1 minus 2, that is minus 1. Last value minus first value. R, 0. Okay, so why it is 0? What is the formula of R? Just, okay, let's see. Now, what will be R? R bar. R bar will be the arithmetic mean of these values. So R1 plus R2 plus R3 plus R4 by how many R's are there? 4 R's are there. So we'll write 4 over here. And what is the value of R1? That is 1. What is the value of R2? That is 0. What is the value of R3? That is 2. What is the value of R4? That is -1. And divided by 4. 1 minus 1, that is 0, 0. And we get 2 by 4, that is 0.5. So your R bar is 0.5. Why it is 0, I don't understand what you are writing. You can mute yourself and you can tell me. Why do you think that it is 0?
স্যার আমি ওটা ভেবেছিলাম যে ওই যে আপনি বলেন লাস্ট ভ্যালু মাইনাস ফার্স্ট ভ্যালু, তাই আমি ওইটা ওইভাবে করেছিলাম। না না এটা হবে না, ভুল হয়েছে।
আচ্ছা এখন বুঝতে
পেরেছি, আমি
পেরেছেন?
আর এর ওই হ্যাঁ 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 বুঝতে পেরেছি।
ওকে স্যার, ওকে স্যার। So R bar is has been calculated. It is 0.5. And if you can recall, in the before the sudden disconnection, I calculated my X bar. X bar was calculated. The grand mean was actually which is the estimate of mu was actually calculated, and the value obtained was 1.5. So if you are interested about mu cap plus 3 by n sigma cap, because mu and sigma are unknown, so we have actually got X bar for mu cap. 3 is there, n is there, and sigma cap is what? In place of sigma cap is formula is given by R bar. What is the formula of sigma cap? R bar by D2. So in place of sigma cap, we will write R bar by D2. So actually, if you talk about UCL, so we have actually calculated X bar, which is 1.5 plus 3 is there, small n is there, R bar is calculated 0.5, rest is D2. We have to talk about it. What is D2? And if you talk about LCL, the same thing, mu cap minus 3 by root n sigma cap, which is X bar minus 3 by root n R bar by D2. So here also we can substitute 1.5 minus 3 by small n 0.5, but a term D2 is there which we don't know. So once we know this D2, once we know this D2 thing, then these particular limits are known to me. Only thing we have to know is D2. We have to know what D2 is. Okay. So this session is going to end soon. In the last session, I'm going to discuss about D2. And for that, I shall ask all of you to open your WhatsApp. And there I sent you a image, JPG image, where a chart was given. So which I shall be requiring that chart for the calculation of D2. Okay, so I'm pausing the video over here. Let us wait for the next session to begin.